talk about angles of rotation. Our objective is for you to be able to draw the angles in what you call the standard position and be able to determine values of the trigonometric functions for a given specific angle, which we can find in the standard position. Let's start defining those terms. All right. When you talk about an angle that is in standard position, essentially what we're trying to explain is that the angle starts from the x-axis. Okay, so if you drew your coordinate plane, you have your x and y axis with a 0 degree starting from the right-hand side. This will always be where you have the initial side or where your angle starts to form. And you have, of course, what you call the terminal side, where the angle ends. So how wide is that specific angle open? Okay, so in this example, we're going to take a look at two specific rotations. We have what you call the positive rotation and the negative rotation. Let's start with the positive rotation. When you say an angle has a positive rotation, the angle actually has a positive measurement. For example, 135 degrees right here can be best represented by starting from the initial side, drawing a line like so, the blue line right here, or the blue ray, where the angle opens 135 degrees, ending on your terminal side, which is about approximately this, where this red ray ends. And this is actually the opening of your positive angle. Okay, to say the angle is in standard position is to say that we started from the x-axis at 0 degrees and the angle opened up, doing a counterclockwise rotation, if you want to call it that. On the other hand, to say that there is a negative rotation means that your angles, okay, instead of going toward the left in a counterclockwise direction, a negative rotation is what happens when your angle measurement is negative. For example, negative 45 degrees right here. Instead of going to the left, going up here, you actually intend to go to the other direction, this time taking what you call your clockwise rotation. Now, why is that? Because this time you have a negative angle measure. Your initial side still starts at 0 degrees. The only difference is now all your angles will have a negative measure, which means you do have to go to the clockwise direction. Okay, so in this case, negative 45 degrees is about right here. Okay, and of course you have what you call your terminal side where your angle should end. So that's about it for angles to be in the standard position and whether they have a positive rotation or a negative one. So let's talk further more about the rotations. Sometimes the terminal sides can rotate more. Take note, it can rotate more than 360 degrees. Okay, and you've seen this somehow in your geometry lessons. Let's take a look at a few more examples. All right, so let's go over your circle. In a circle, you know that a complete full rotation, okay, regardless of direction, will produce a 360-degree angle, okay? But you also know that in that circle, you can divide the circle into 4 parts, where you have the first quadrant, okay, which will be a 90-degree measure. The second quadrant from 90 degrees to 180 degrees, because you know half of a circle is 180. And on the third quadrant, from 0 degrees all the way to the third quadrant, you will produce a 270-degree measure. And of course, your fourth quadrant is from 270 degrees to the rotation, the full rotation, which is 360 degrees. And this is when you have a positive, right? When you have a positive rotation. So let's take a look at a circle which has a negative rotation. Okay, I'm going to use a red pen so you can really see the difference. All right, so positive is going to the left. This time I'm going to produce the circle with negative measures. All right, so still starting at 0 degrees because we want our angles in standard form. Okay, so instead of going to the left, I'm actually going to the right or in a clockwise direction. What used to be 270 degrees for a positive rotation is actually a negative 90 degrees for a negative rotation. And so over here, it remains to be 180 degrees. However, it will be negative. Okay, continuing. What used to be 90 degrees, because now we're working on a negative measurement, this will become negative 270 degrees up here. And of course, your full rotation back to 360, but because we went the opposite direction, we say that it is a negative 360 degrees. So the science right now at this point is just telling you which way your angle is rotating. Is it doing a clockwise or a counterclockwise rotation? All right, let's bring you forward. Okay, so we'll look at a few examples right here. Make sure we understand how the angles would look like. We also mentioned that it is possible for the rotation to go over 360 degrees because you might need to take more times going around the circle or around the angle measure. Okay, so let's take a look at the first example right here. We are instructed to draw the angle at 300 degrees in standard position. Okay, let me use my blue pen. All right. So 300 degrees, as you remember, we started at 0 right here. You have your 90, you have your 180, and your 270. So going around, all right, going around 300 degrees is way beyond 270, which is way less than 360, less than a complete rotation, right? So we start from the standard point, the initial side on this x-axis, draw your angle opening, and show the terminal side with another ray right here to show that this whole rotation is going to take 300 degrees. And this is already the illustration that you're expected to produce to show the standard position. Okay, all right. In the same manner, in example B, you are required to show negative 150 degrees. Okay, so remember, this is a negative rotation. So are you going to the left or are you going downward? So that's the question you have to ask yourself. Okay, because it's negative, you want to go this direction. All right, so initial side on the x-axis, starting from here. Okay, standard form, 0 degrees. But I'm looking for negative 150. So illustrate this for yourself again. Especially now that we're still starting out, it really helps that you know where your measures are. So this will be my negative 90, negative 180, negative 270, and then back again to a complete negative 360 degree measure. Because I'm looking for negative 150, I know it's between my 90 degree and negative 180 degree measure. And because it's negative, I'm going this way, opening my angle, okay, making sure I show the terminal side with another ray right here. And this will represent your angle in standard form, okay? So we've done a positive and a negative rotation. Now let's bring up that information that we were looking at a while ago. We said that sometimes your angle rotation would be more than 360 degrees. So in part C, we're instructed to illustrate a 900-degree rotation. How would that look like? So this is where you have to show multiple rings. Okay, notice how there's multiple rows happening here. So let's break this down into the different parts. You know that a complete rotation is 360 degrees. Okay, 2 rotations this time will be twice of this. Okay, so we're so close to 900 degrees, but we're only looking for 900 degrees. So it's still beyond 720 degrees. So this is 1 rotation, 2 rotations. Okay, so we need to go over 2 rotations. So let's see. How many degrees would 3 complete rotations take? Okay, that's a question you ask yourself. So it's about 1080 degrees right there. Okay, so if that's the case, okay, notice how the rings that were formed here, let's follow it along. Standard position, starting from the x-axis, positive angle, so I'm going up this way, okay, follow the mouse over. So this will be 1 complete rotation. This is me stopping here at a 360-degree angle, right? Okay. We need to go further. Now let's do another complete rotation to get to the 720-degree rotation right here. Okay, so at this point, we've completed 2 rotations, but we still need a little bit more to get to 900, which is between 720 and 180. The question is, if this is already 720 degrees, right, where would 900 degrees end? So this is where you need to find the other measures just to give you some more idea. Okay, so let's break this down. If this is 720 right here, and you need to add 90 more degrees, so you would go 720 plus 90. This right here is actually 810 degrees. Okay, all right, we're so close to 900 degrees. Okay, so from here you need to add another 90 degrees to find the other remaining section. So this is going to end up on 900 degrees. Luckily, it's an exact measure. So we say, okay, from 720, I actually just need to add 180 degrees to complete my 900-degree rotation. So this is, again, notice how from 720, the remaining measure ends up on here. So then we draw your terminal side, and this illustration right here best represents the rotation for a 900-degree angle. Okay, so it's possible. It's possible to have more than a single rotation, maybe two or more, etc. It's okay. It's part of the instruction. Okay, so let's have you try on a few more examples. At this point, you can pause the video so that you can practice first and give yourself a chance to take a look at the answers. Okay, I'm continuing now. All right, so try this. Draw an angle with the given measures in standard position. Remember, starting from the x-axis at a 0-degree measure, and making sure you know which direction you're going to take, if it's a positive or a negative measure. Let's start. 1A is a 210-degree measurement, so you're going to the positive direction. Let's take a look at what that would look like. All right, so illustrated right here, starting at the initial point, initial side, you're opening to the left in a counterclockwise direction, where 210 degrees is about somewhere in between 180 and 270. So I'll put my terminal side right here. And this is already a representation of your 210-degree measure. Okay. Meanwhile, in the second example, you have 1020 degrees. Okay, way more than a single rotation. And it's also positive. So let's take a look at the illustration. Okay, so 1020 degrees, we can list them down again. Make sure we are confirming how many rotations we really need to take. All right, so let's take a note right here. 360 degrees, a complete full single rotation. 2 rotations is 720 degrees. Okay, not enough. But then the third, 3 complete rotations is 1080, which is way, way closer than what we want for 1020 degrees. That means we're almost completing 3 rotations, but not really. So let's take a look at this. All right, let me use my mouse. All right, so a single complete rotation ends up on this point right here. But then you need to take another complete rotation at 720 degrees. I'm ending right here. All right, so at 720, we figured out that 1020 is almost 3 complete revolutions or rotations, but not quite. It's about 60 degrees short. So from here, let me go ahead and try and do an almost complete rotation, but not really, which is about here, because I only need about this much to complete my 1020-degree measure. And yes, you will have multiple rings, just like what you did in the past example. All right? Okay, in the next example, you have negative 300 degrees. All right, so now you have a negative measurement. You're going the opposite direction. Okay, let's take a look at the given graph. So remember that your measures are now going to be negative, and you're going the opposite direction, where negative 300 degrees from the initial side will now go this way, clockwise, almost reaching a full rotation, but not really, 60 degrees short, and you place your terminal side to show your rotation. Okay, so hopefully you were able to go over this. Feel free to pause the video at any point so you can review the questions. Let's go forward. All right, so now we know how to illustrate the angles in standard form based on their rotations. Let's talk about what you call your coterminal angles. Okay, so coterminal angles are the kinds of angles. Okay, they're actually angles in standard position which end on the same terminal side. They basically end on the same point, except that there are infinitely many possible combinations. Okay? All right, so maybe let's try and illustrate this right here. I have, okay, let me use the red pen and show you. Say I'm producing this angle right here. All right, say this is this angle right here with a specific measure, right? All right, to say that there is a coterminal side means this. Just by this angle alone, one can produce another rotation that ends there. Did you see that? But that means that's only one of the possible coterminal angles. I can also produce another rotation and still end on the same terminal side. Okay, so those are coterminal angles. There could be two or more or infinitely more coterminal measures. In the same manner, you can also have negative measures. Okay, so starting from the initial side, instead of going the positive direction, I can go the negative direction. But see, I can also end over here on the same terminal side, but this time with a negative measurement. All right, so let's actually observe a few examples down below. All right, so in order to find coterminal angles, you either add or subtract multiples of 360. So it's very much like what we've done with the 360 degrees, 720 degrees, and so on and so forth. Okay, to say that there are positive and negative coterminal measures, okay, is actually to find a positive measure and a negative measurement. All right, let's see what that looks like. So 40 degrees, you can illustrate this if you're a very visual individual. 40 degrees, we say it's about right here. Okay, so let's draw out your angle measurement. This right here is a pretty okay representative of a 40-degree angle measurement. Question is, how do you find coterminal angles to this terminal side here? Here's a suggestion. There are so many possible answers that you can start by doing this for now. What you can do is to add 360 degrees to that angle measure, okay? And this will produce one of the positive coterminal measures. If in the future you're instructed to find more than one, here's another thing you can do. Because you're looking for a positive measure, there's another or multiple possible answers. Instead of just adding a single 360-degree rotation, you can add another one. And that's what we mean by multiples. You can add or subtract multiples of 360. So this is about 760-degree measure, which is both positive, right? Because we're looking for a positive measure. Positive measurements that are coterminal to a 40-degree angle. In the same manner, if we're instructed to find a negative measurement, all right, instead of adding 360, you will definitely be subtracting that from 40 degrees. Thus, you have your negative 320-degree measure. So what that means is instead of going the positive direction, you're actually looking for an angle measure that has a negative value going in a clockwise direction, ending on the same terminal side. Okay, so then again, what if you were instructed to find two of those? So you can subtract 360 degrees another time, okay, so twice really, and then that will give you something closer to a negative 300. What was this? 300, let's see, 720, right? So 720 negative plus 40 degrees will give you your negative 680-degree measure. So it is possible for the rotation to take more than a single ring, as you saw in our example here. And there are multiple possible answers for each of them. As long as you're adding 360 degrees or subtracting 360 degrees, you're able to find coterminal angles. Let's take a look at the next one right here. For a 380-degree angle, okay, so that's way more than a single complete revolution or rotation. Let me draw my terminal side right here. I know I'm going the positive direction and I end up something along this point right here. Drawing my terminal side like so. All right. Okay, and yes, you do want to create your rotation from the middle going outward, your spiral this way, okay? All right, So 380 degrees, let's find a positive measure that is a coterminal measure to 380 degrees. Now, initially, some of you will do 380 degrees plus 360 degrees, which is awesome, okay? And you will get 740. That is a coterminal through 380. We end on the same point. However, some of you might also find a positive measure. Instead of adding 360, you can subtract 360. Because don't you get a positive 20 degrees anyway? It's a positive measure and you want a positive measure. But wait, Mrs. Forrest, you said to just add and find a positive measure. Why are we subtracting now? Okay, that's a really great question. You need to think about this. We're looking for a positive measure, the positive angle measure, a coterminal that's positive. It doesn't really matter what operation you're using as long as you find positive measures. So it is okay to use the subtraction of 360 or subtract 360 to find a positive angle measure, because sometimes that's the only way you can find the specific measure you're looking for. Okay, so let's go ahead and find a negative measurement. To find a negative measurement, as you can see, once we subtracted 360, it's not even enough. It's still a positive measure. So you can go ahead in the same manner, subtract 360 twice so that we can find your negative measurement. So this is about negative 340 degrees. You can pause the video right now and take a look at the few examples we have here to practice on them. Find the measures of a positive and a negative angle that are coterminal with the given. Again, if you're a visual individual, you can illustrate them first to help you further see them. Otherwise, you're adding or subtracting 360 degrees or multiples of 360 degrees. Let's go ahead and check for the first one. You have an 88-degree angle measure. To find a positive angle, okay, you have the option to add 360 to 88 degrees a single time to get the given. Or you can add multiple times and keep getting positive measurements. Okay, remember, to find a positive coterminal means to find a positive measure in the end. And to get a negative measure, okay, we can subtract 360 degrees a single time, and that will produce a negative measurement. And if you need more of these, you can keep subtracting multiples of 360 degrees to find those measures. In the same manner, in the second example, you have a 500-degree measure. To find a positive measure, some of you, okay, will do the following. Some of you will add 360 degrees. Okay, if you did this, that is correct. But some of you were thinking, okay, well, what if I didn't add 360? What if instead I subtracted 360 and instead I got 140 degrees, which is also positive? Is that a correct answer? Yes, it is. Because remember, to find a positive measure means to end up with a positive measurement over here, and it doesn't matter if you're adding or subtracting 360. Okay? And to get a negative measurement, as you can tell, subtracting a single 360-degree measure is not enough, so you will need to subtract one more time, and that will produce one of the many possible answers. Okay, in the same manner, if you have a negative measure in the last example, negative 120 degrees, what you can do to find a positive measure is to add 360, like so. And once you do that, you will find a positive measure. Now, some of you will continue to add 360 degrees and get other measures. As long as they're positive, they're correct. On the other hand, to find a negative measure, okay, one can subtract negative 360 degrees. And if you need more answers, again, keep subtracting multiples of 360. Okay, so hopefully we were able to get these possible coterminal measures. Let's bring you forward now. All right, so in the next section, we will talk about what you call the reference angles. Okay, what are reference angles? So think about your, when you start applying for jobs, some of you are writing your resumes. When you look for a reference or you ask for a reference from someone, you really want someone who knows you really well. And of course, to write a reference means to build up your character, to write something very positive about you, right? In the same manner, to say that we're looking for what you call the reference angles are always going to be positive. So please take note. They will always be positive measures, which are acute, less than 90 degrees, and they're formed in this manner. They're formed by the terminal side, wherever the angle ends, toward the x-axis. Okay, so let's look at a visual right here. So to say that this is a reference angle, first you're instructed to take a look at this blue angle measure here, theta. This is theta, whatever that measure is. Now to find the reference angle to that given is to simply look at the terminal side, it ends here, and find the remaining measurement toward the x-axis. So how far away is this terminal side to the x-axis? That is what you would call your reference angle. Okay, so let's take a look at the examples below. All right, take a look at the first one. If you have 150 degrees, okay, so you need to start by looking at the illustration. Again, if you're a very visual individual, this is a really good way of looking at it. Draw your angle measure, initial side toward the terminal side. Question is, what is the reference angle for a 150-degree measure? Now that you've illustrated this, question is, how far away is 150 degrees, this terminal side, this line right here, this ray, how far away is that from the x-axis? Okay, so you need to find the measure. So right now, you're familiar with your coordinate plane, you know the angle measures. If this is 150 right here, okay, how far away is it from the x-axis, which is actually this same line right here, which is about 180 degrees. So how far away is it? That's how you know that the reference angle, okay, is actually 30 degrees, because that's the distance from 150 to 180. So it's always a reference from 180 or 360 degrees or 0 degrees if that's the case. And it always needs to be positive and acute, always. All right, let's take a look at the second example. I have a negative measurement, negative 130. You know you're going the clockwise direction, going this way, okay, where the terminal side ends here. But now because the terminal side ends here, you ask yourself, well, how far away is this point to the x-axis? You understand this is a negative 180-degree measure because it's a negative direction. However, okay, remember that it needs to be a positive, acute measurement. To say that from 130, when you think of the absolute value, from 130 to 180, it's actually 50 degrees. So we say the reference angle is actually 50 degrees. That's how far away the opening is from the x-axis, the remaining measurement. Okay. All right, let's look at part C. 280 degrees. I am going a positive direction, going counterclockwise, a little bit over 270 right here. This is my terminal side. Notice how this time you're going to look at this perspective from 280 degrees right here. How far away is 280 degrees from a complete rotation? Why a rotation, right? Because right now you're not looking at 180 anymore. You're looking at the x-axis where you're actually almost completing the rotation at 360 degrees. So question is, how far away is 280 degrees to reach 360 degrees? And that's how we can come up with the answer that, oh, it's actually 80 degrees. It's a reference angle, it's positive, and it's acute. All right? So let's give you an opportunity to practice working on these examples. At this point, you can pause the video so that you can practice answering the following questions. All right, so find the measure of the reference angle for each of the given. Let's take a look at the first one. To find a reference angle from 105 degrees, okay, you have the option to illustrate it like so. So I drew my angle as the red initial and terminal side right here. The question is, how far away is 105 to 180 degrees? This is the reference angle I'm looking for. And in order to find that, you can do some subtraction. I did 180 and subtracted 105 degrees. Thus, my reference angle is actually 75 degrees. It is acute and it is positive. Let's take a look at the second example. I have a negative angle measure, okay, illustration right here. I am going clockwise, in a clockwise direction. So now I end on the terminal side over here at negative 115. Question is, how far away is that point to the negative 180 degrees? Remembering that a reference angle needs to be positive. So what you can do is take the absolute values, okay? So you would do 180 degrees and subtract 115. so that you end up with a positive measure because that's what you want for a reference angle. And that's how far away 115 is from 180. All right, and then the last one, you have a 310-degree measure. Here's my illustration. It is taking a positive rotation, ending somewhere about right here. Now, again, instead of asking yourself for 180 because you're in a different quadrant, you're way closer to 360 than you are to 180. And you know reference angles need to be acute. So ask yourself, how far away is 310 degrees from 360 degrees? So you can do some subtraction, all right? And we end up with 50 degrees right here. Okay, so hopefully we're addressing some questions you have. How do you know when to end? How do you know if I'm using 180 or 360 degrees? You really need to look at a visual if that helps you. Or you need to think of your values, your measures. Is it closer to 180 or is it closer to 360? At the same time, you also need to take note. Reference angles need to be positive and need to be acute measurements. All right, let's go forward. Here's the last section of this lesson. We're going to talk about trigonometric functions. You'll remember your sine, cosine, and tangent functions. You also remember that to find one of the missing sides, you have the option to use your Pythagorean theorem. Okay, so you're familiar with these things. What I want to share with you right now is how to use that information to generate illustrations on a coordinate plane. In your previous math classes, you were taught that these are the quadrants, the 4 different quadrants, right? However, in order to apply your trigonometric functions, we need to illustrate the following triangles, okay? These are going to represent the different portions of those quadrants, where you can put a point P, this is a location right here, point P, in quadrant 2 with a given x and y measures, including a hypotenuse measurement. Okay, so visually, it looks something like this. There is a point P with the given coordinates x, y, and you will have specific measures right here. Those are your x and y values. Let's take a closer look at this and what it means to us. All right, so this example is taken straight from your book, Finding Values of Trigonometric Functions. There is a point P, which has a location for -5. Okay, so initially, think of that location. In which quadrant would you find for -5, right? You know you'll find it in the 4th quadrant. So let me illustrate what we had in the previous slide. Remember this illustration? This is actually a very helpful tool to choose which quadrant you're drawing this point on. Okay, so for -5, as you said, is in the 4th quadrant right here. Notice how the triangle resembles what we have in the ribbon trick that we produced, okay? All right, where the angle theta is going to be right here, right there. Where this point right here is for -5. All right, so it's asking us to find the exact value of the 6 trigonometric functions. What are the 6 again? You have your sine, you have your cosine, tangent, your reciprocals, cosecant, secant, and cotangent. All right, so we plotted our point. Step 1, plot the point, like so. We placed point P, and now we produce your right triangle, based on the trick from the last slide. Now, our objective is to identify what the coordinate point means. Because you're in the 4th quadrant, it's actually telling you that the 4 here, the x-coordinate, is the distance from the middle point to this point. It's 4 units away, where the -5 is your y value. From the x-axis toward this point, this measures -5. But Mrs. Forrest, there's no measure that's a -5. Yes, we understand that. That's why we said when you're talking about lengths, you need to consider the absolute value. But why are we using -5, right? -5 is just telling you the direction of the point. Where is the point located? So it's more of a, what do you call it? A direction, which way you're taking the point, okay? So given the following, we really want to look for this hypotenuse measure. And like you said, you can use your Pythagorean theorem. If you're looking for the hypotenuse, you would square the legs and find their sum, and then obtain the square root. In this case, we found it to be √41. Okay? All right, so we are ready to find your trigonometric functions, where your sine is the opposite over the hypotenuse. Okay, opposite over the height. Let's look at the triangle we generated. What's opposite this theta measure? Opposite is -5 over the hypotenuse, which is root 41. And that's how we produce the following. But how do we get from this step to the next one, right? That's a really great question. Where did that come from? Do you guys remember rationalizing? This was the topic we brought up during our conference if you attended it. All right, so we say to rationalize is to multiply, right? To multiply the expression by the denominator so that we won't have a radical expression in the bottom. That's how we generate -5 root 41 over 41. Okay. In the same manner, cosine theta is the adjacent over the hypotenuse. Let's look at this. Adjacent to this measure, this theta is 4 over root 41, like so. And once again, you have to rationalize. On the other hand, for a tangent function, you need the opposite and divide it by the adjacent. So the opposite of this theta is -5 over the adjacent, which is 4. So those are your 3 original trigonometric functions, where now we need to look for the other 3, your reciprocals. Now, when you talk about the sine theta, okay, the reciprocal is cosecant. What you can do is this. Go back to the initial expression you created. Express it as the reciprocal. If we do that, you will produce your negative root 41 over 5 right here. In the same manner, cosine's reciprocal is secant. So instead of 4 over root 41, you produce root 41 over 4. And for tangent, instead of the opposite over adjacent, like -5/4, you find the reciprocal -4/5. And this is how you can use the trick that we showed in the previous slide. Take note of which quadrant you will find your right triangle in, and try to illustrate that so you have a visual of where theta would be. Okay, so at this point, I'm going to show you one example that we will work on. Okay, you can pause the video at this time, give yourself a chance to practice. Okay, all right, let me continue. So I will illustrate my very nice trick first, where the middle measures are the theta. Okay, where the right angles are the corners here. Okay, all right, so 3, -3, 6, which quadrant would we find that in? So -3, 6 is going to be in quadrant number 2. Okay, quadrant number 2. All right, so quadrant number 2 will develop a graph that will look like this, because we're in the second quadrant, where this is the right angle and this is theta. So -3 will be, so this point right here is -3, 6, point P is right here, where the x value is -3 and the y is 6, right? Okay, so our objective is to find the 6 trigonometric functions. And in order for us to do that, okay, we need to find first the length of the hypotenuse right here. So how long would that be? Let's see. We're going to use your Pythagorean theorem. You're going to square each of your legs, right? Add them up, find the sum, and then find the square root. In this case, I'm finding it to be root 45. Okay, please do not give a decimal. Here's what you should do instead. Think of simplifying root 45. Okay, we're going to factor this out. What are factors of 45? Yep, you have your 9, you have your 5. But remember, these are square roots of 9 and square root of 5. Where you know the square root of 5 is not exact, so we leave it as root 5. However, you know the square root of 9 is 3, so we say, okay, the hypotenuse actually has a length of 3 root 5 right here. All right, awesome. We have all our sides. We're ready to find your 6 trigonometric functions. Let's start with sine theta. Sine theta, theta's right here, remember? Okay, sine is opposite over hypotenuse, where you have your opposite, which is 6 over 3 root 5. Let's write it down right here. 6 over 3 root 5. Simplifying this first, 6 can be divided by 3. So we have a 2 over root 5. Is this an okay answer? No. You want to rationalize. So let's multiply by root 5 over root 5. Thus, we have 2 root 5 over 5. This is sine theta right here. All right? Okay, so let's bring you closer to the next step. Cosine theta, let's look for cosine theta. Cosine theta is the adjacent side, -3, over 3 root 5, like so. Okay, so let's simplify. 3 and 3 can be divided, so you have a -1 over root 5. Once again, you need to rationalize. Rationalizing -1 root 5, okay, over +5, or simply you can say cosine theta is -root 5 over 5, and that's okay. You can leave it this way, you can have the 1, it's okay. Now for tangent theta, let's look for tangent theta. It's the opposite side, which is 6 over -3. So you simplify it further, you have a -2. That's your tangent theta. Now that we have the first 3, let's look for the other 3, your reciprocals. Let's start with cosecant. Cosecant, the reciprocal of sine. All right, so please do not use the final answer. Go back to the beginning of sine theta. How did you find sine theta? Use that information and find the reciprocal. So I would put 3 root 5 in the numerator and divide it by 6 instead. Now I can simplify further. I can simplify 3 over 6 as root 5 over 2. This right here is representative of cosecant theta. Now let's find secant theta. Okay, so go back to cosine right here. Go back to the beginning steps you took. Let me write 3 root 5 in the numerator and -3 in the denominator, so that I can simplify 3 and 3 into -1. So really, secant theta is -root 5. And also for cotangent, the reciprocal of your tangent function, okay, you will put -3 in the numerator, 6 in the denominator. This time, it will be a -1/2. All right, so this is all about angles and its rotations, whether you're taking a positive or negative direction. You were also able to find what you call coterminal angles, where you have to add or subtract multiples of 360 so that you can determine the angles that can end on the same terminal side. And then you went on to work on finding reference angles, where reference angles need to be positive and acute measurements. And then eventually, we were able to apply these information into generating and answering problems given a set of point or a point and identifying the 6 trigonometric functions for the given. So hopefully we're answering questions you may have or that have come up. Otherwise, please take note of them, list them down, and we'll discuss them for tutoring. I'll see you soon. Bye.